Hey everybody, this is Larry. I'm doing the Leetcode Weekly Contest 169. I have 30 seconds to go, so wish me luck as usual. Um, yeah, hit the like button, hit the follow button, or whatever, subscribe button, whatever buttons are there. I don't know. But, um, but yeah, let's just kind of have a good contest, have a clean contest, and no silly mistakes. As that's what I always try to go for. But we shall see. But 4, 3. Yep. I dropped something as I was starting. And I was trying to get my pen and paper ready, but I actually hit something. But yeah, for the first problem, I saw this immediately. I think I've been practicing some of the easy ones for fun. So I think when I saw this, I knew immediately that, well, there are two cases. One is odd and one is even. And I was a little bit worried about off by ones, of course. But my idea is just to take, if you want to sum to zero, you just take the odd half and then even number, the positive numbers and the negative numbers, and then they would cancel out. And then I just have to care about odd and evens. And I think that's it, pretty much. And I think I was a little bit slower than I needed to be, just because I was a little bit worried. But because we were about off by one, and also I don't need to be that fast, so it's okay. But yeah. Um, that's pretty much it. And then I test one thing that for this one specifically that I was sure to test was the even numbers. Just really wanted to make sure. But yeah, I was a little bit deliberately slower than usual. But binary search trees or elements. So this one, I yeah, you just have to do a depth first search to go through it. I think I realized how to do this immediately. I just wasn't sure that I was missing anything. I could have double checked actually. But as a result, I was a little bit more deliberate in that, like I was testing more cases than I would have normally, I think. But for something that I probably would have considered this to be easy, to be honest, because you just because it's just a tree traversal, and then you just and then you just sort it afterwards. And given that n is at most 5,000 times two trees, uh, I'm not going to worry about performance at all in this problem. Everything is linear minus the sorting. The sorting is, n log n, but for 10,000, n log n is nothing. So yeah, that's pretty much it. I think I was pretty confident on this problem, to be honest. So I could have, if I have submitted now, I could have saved 1 minute. But it's not a big deal. I think for this one, I just really worried about some edge cases. I just put another case just in case, but the edge case, and they really should make this experience a little bit easier. But the edge case that I worried about was just the empty root. The ones without the whatchamacallit. Like the empty tree. So I kind of got a little lazy and just reword the order, but yeah, seeing that it worked okay, so I just submit. It was, I added like a minute, but I think I just wanted to make sure I was right. Jump game 3. This was also straightforward in that, I've done a lot of breadth first search problems recently, so immediately, especially given that this is a binary problem and that is true or false, I just have to breadth first search and I don't even have to keep track of distance. So yeah, given that n is about 50,000, everything is going to be linear, right? Because you only relax each node once. So I'm pretty sure that's correct, and I pretty much do this immediately, and I've done this plenty of time, even though maybe I could have been slightly faster, but I think I'm okay with that. Yeah. Yeah, and this is just standard breadth search. Yeah, I think at this point, to be honest, I think I just wanted to um, double check the prompt because I thought it was a little bit too easy. Um, I mean, it's not meant to be a brag. Maybe it does come up that way, but sometimes like your spider senses are like, this is too easy. Maybe I'm missing something obvious, you know. And I think um, I definitely felt that here, and that's why I kind of wasn't as fast as I needed to be. And I think one more thing about these kind of problems, where yeah, it is kind of easier in terms of certain types of like edge cases for because it's binary, so you don't have to like worry about distance and stuff like that. But the thing that I would worry about is that just because you pass all the example tests, it might not be good enough because it's binary. So you may just get unlucky, or there's an like it's true or false. So like it's not quite 50%, but like if you're right, maybe you just have some confidence, but not all the confidence, right? So that's kind of the thing that I was worried about for sure. Um, yeah, but so I did run the test. It looked okay, and the problem is still very straightforward. So I was eager to move on, and then I did. Yeah, last problem. Yeah, I mean, I think for this one, my immediate reaction was to kind of look at the constraints a lot, because in many ways, I knew that this was going to be an exhaustive search. That's just from like experience and and kind of like I've seen this problem or like problem before, but I probably solved it like a decade ago or something like that, right? And and I knew that was going to be exhaustive search, and that's the kind of like a little bit. And this is not a criticism per se, but it's kind of like it's kind of tricky to get these things right because you have to mind read a little bit because you like at the worst case everything is going to be like 10 factorial, which is whatever. I mean, maybe could do more precise math on what that actually means in sense of there's non-zero leading digits and stuff like that, so it's not exactly 10 factorial, but it does do that much work in the worst case possibly. But there so I did initially try to do this with a very straightforward depth first search proof first. Like for every letter that we encounter, just try a number. But it was timing out a lot, and I end up getting that about um, let's see. I think I end up getting that about 20 minutes into this problem, um, and then yeah, and then it was timing out and everything as kind of expected. And then I was just, well, let's start from scratch. I mean, I knew the way to do it is that there are like some obvious pruning with respect to like, okay, let's take the last digit. That's only considered recursion on the last digit where like the last digit of the first word plus the last digit of the second word is equal to the last digit of the last word, and so forth, right? Maybe with a carry if we go on other digits, but that's essentially what I set out to do. I'll put a link. I mean, yeah, I'll put a link below to kind of so you can skip ahead to that part, see me typing that part. I think some of my hesitation is that, as again, because it's a little bit mind reading kind of thing. Like I wasn't sure that one optimization is enough, right? Especially the way Leetcode kind of structured the test, where they run all the tests together. So it's not like a per test case has a certain amount of time. So because of that, you're really relying on the system or like the inputs to be kind of like, match whatever pruning strategies that you're doing, right? So that's kind of the thing that I was worried about. But and it so I did the exhaustive search, and then I kind of do the slightly optimized exhaustive search about 30 something into this video. I'll put a link below. But yeah, but that's basically it. I think those were my entire dot. I mean, it ended up taking me about an hour to program it. Half an hour, 20 minutes or so for the first exhaustive search, and then maybe like 30 minutes and 40 minutes on the latter one. I had some mistakes here and there on implementation, some off by ones and using the wrong library in one place, which which you learn, but otherwise still pretty okay. I mean, I think it's something that like it was kind of cool to implement it. And I think the only thing that I maybe wish a little bit is that yeah, things did okay. But cool. Well, I think I'm gonna leave the commentary off now. But yeah, definitely check out the links below to kind of skip ahead a little bit. And I'll go over the problems later. Anyway, see you from this head. Oh. That's not good. It's very inconsistent. Already finish everything? Wow. So I was having issues, but I'll probably also could do a little bit better. It's 8 times. This may even be wrong, but Is that even right? I guess that's right. But it could barely pass, even the examples. I mean, brute force is probably the best you can do. Just have to prune it a little bit. It's gonna be one of those mind reading ones, but Okay. Such a mess. How do it went fast enough for now. Finally. Just kidding. One combinations. I might not get this one, to be honest. We want combinations anyway. Never does a recursion. One's fast but wrong. Trade-offs. Debugging is very expensive. Combinations is wrong. No permutations. Got a little confused. Ooh, oh, that was tough. I mean, I don't know where I finished by 55. I mean, that was way tougher than I mean, whew, all right. I mean, this is not updated, so maybe I do a little bit better. But that was my chance. I mean, I took my time with the last one just because I knew that if I get it right, I'll be in a good place. It was a messy poem. I mean, I think I was top 10 after three poems. I was very fast, but uh, you know, did I? How come I did get it right? Right? Like, hmm? Did I have to submit again? I should submit again. It seems like they have some difficulties. Well, I hope they sort it out. But I mean, either way, I mean, ADP got away. I mean, yeah. I thought, how long did that end up taking? About an hour. So that'll probably put me in top 50. It's okay. I think if I mean, if I had a really good, if I had a very easy, I mean, I think I don't know. I mean, I'll have to see to know. But I mean, this is a very common-ish poem, so I feel like some people have solved it just because it's one of those like traditional classic poems. But that said, probably could have done faster. But I don't know. I don't even know if I actually got it right, to be honest. So we'll see how that goes. But I'm 56 without the poem, so that's kind of good. I guess that's good considering not solving a poem. But congrats to Face and the usual people. But yeah, let's kind of go over the statements. I think I end up taking some time, like to be deliberate. But you know, that was a hard problem. But no idea. I'm not sure why this is not updated. But anyway, we'll go over the problems. I mean, at worst, it is what it is. I mean, I'm here to learn, not necessarily for high score. Though high scores would be nice too. So, but cool. Um, Yeah, so the easy one, find and unique sums after zero. I did this in about a minute and 26 seconds. Um, I think I noticed that all the examples, I mean, this is pretty straightforward. I noticed that all the examples are odd. So I just wanted to double check easy and, double check the even numbers. And I just wanted to double check. So I took a little bit more time than I needed. But basically, the idea is if it's odd number of numbers, just take zero and then just count to the half of it. And if it's even, then you do the same and it evens out, right? Quote unquote. Okay. And then Q2, all the elements and binary search tree. So yeah, it's just a very straightforward recursion. Add nodes to a thing and then sort it. And this is just recursion, right? This is as simple as a recursion as it goes. I do pre-order. Yeah, I do pre-order, but it doesn't really matter. And with 5,000 elements or 10,000 on two trees, like performance is not an issue. So yeah. And the third one, very straightforward breadth first search. Basically, we start at the index start, and then we just kind of go to see if we could get to the point given these rules. And you could do a BFS on it. So yeah, relatively straightforward. Uh, yeah, and then the hard one is I did this with another way. I tried the brute force one just to see if it would have worked. But man, this is very discerning. Um, but but yeah, so the idea that I end up doing was just doing more on. I mean, I tried it; it was too slow. I couldn't even get close to running. But here, instead, I try to do it digit by digit to kind of prune it out a little bit. So like you start with the ones digit and then see if you could possibly add it to the last digit, and then you kind of keep going on that, and that's kind of generally my idea. Yeah, cool. And then everything else is just recursion, and like you call it depth search, but it's just recursion, just kind of exhaustive search for the mapping. Cool. Yeah, that's all I have for now. I'm going to do code review pretty soon, so I'll see you right now. Cool. Yeah, so I finished 72nd. Luckily, thankfully, the last farm finally counted. So I'm 72nd out of 6,000 is not that bad. I mean, I probably could have done farm 4 a little faster. I think in general, oh, they haven't released the contest. Oh, there we go. In general, I took a lot of time on Palm 4 just thinking about I was just trying to be exhaustive search without doing the more the optimizations, and I think that's the tricky thing with these optimization ones is that you have to mind read, and to be honest, like after that one optimization, do you know if that's going to be good enough? Wasn't super sure, but anyway, here's the learning portion where I do code reviews. So let's kind of look at what I can learn from other people. Let's see, the problem one was the sum to zero one, I think. I always like to use. Yeah, it's the same thing I did pretty much. So that's kind of cool. Minus this. Oh, this is just. Oh, that's another way of doing it. Wow, that's also smart. I don't know about the constraints, but basically it just takes the first n numbers and takes the negative number. Makes sense. That took me a little bit too long to read because I didn't know if I expected something different. This is the same as mine. Yep. So pretty, I like the others just to see other, possibilities, and this one certainly had them. So yeah, uh, this is finally a contest where the leaderboard is dominated by the last farm. So that's kind of good finally, instead of like having a pure coding, a typing contest type thing. Also, my rank went back up, but that's because I guess the other server isn't up. But okay, let me see if I refresh so I could kind of see more solutions, especially from my fellow, my insane Chinese people. Okay, same idea I did. Yeah, oh, he went to some strategy as well, very good. Um, Cool. And then the second one is is it the tree one? Yeah, it's the tree one. So I imagine everyone looks roughly the same. This one looks same-ish. Um, yeah, it looks the same-ish. Shamish. A lot of typing, but I clicked on that already. Yeah, let's see. 10 seconds, really? I'm going to have two depth of search just in case. Um, But he typed two depth of search faster than I did one depth of search. So okay, problem 3 is the buffer search. So there's a lot of searching today. Now that I think about it. Um, yeah, I mean, I don't know if I expect anything that different. This is a queue. Also a queue. Yeah, another queue. Everyone's looks the same ish. What is this? Also a queue. Just a queue that's in whatchamacallit, in an array. Yeah, I guess everyone mostly look the same. So cool. And and now the last one. Mine is a little bit of a mess, but actually look, not terrible. I took longer than I should have, but that's fine. 13 minutes. I mean, this is a very compact solution. What is the? Oh, using a bit mask is also smart. That's what I maybe should have done, but what is going on here? Huh. Not sure I understand this recursion, but it's very good. Keeps track of a current sum. Actually, not sure if I understand that one, but let's look at another one. How is this fast enough? To be honest, because I tried to do something like that, but maybe it was fast enough. Maybe I didn't really need it, some optimization, but I was getting a lot of. Um, no, he does some smart stuff on the. Not sure if I understand his thing. How is he going? I'm gonna have to do a read up after this. There clearly different ways to solve this, and that is much cleaner. That I maybe involve logic that I did not realize on. This is more similar to what I did, kind of. Um, yeah, people also. I think one thing that I also noticed that I could also keep track of the running sum, but I guess that doesn't matter. I mean, if I just do the carry, it's about the same. I think I did a little bit extra work to do that, so that's good. Another depth first search one on the sum. Might have to do some reading. I think maybe that's why I end up taking so long. Um, this is similar to mine. Let's see what the. I see the depth search on 3 states. I think that's something that maybe I have to kind of see what they're doing. They definitely do some pruning. I think that's something that I. What is POS? POS is. This is the only place where it changes. But maybe word by word. I don't know. But people do variation of kind of the last digit type thing, or keeping track of the current sums to remove branching. I did. Well, at the very least, they. At the very least, they keep track of it so that I mean, I guess there's no digit per digit pruning here, but they keep track of it so that they don't have. So it saves. Because I do this thing where on every at least initially on my first recursion, I do this thing where on every recursion I do the math every time, and maybe that is too brute forcey. Or maybe that's just. I mean, that definitely adds a factor of like 5 slower or something like that. Maybe if I made that change, I'm gonna play around with it later. But yeah, overall, yeah, just different variations of backpacking, and it's kind of interesting to see how people kind of remove just enough to pass the examples. They definitely are smart enough to kind of make sure that they do it in character or digital order. There is some like funky stuff. I don't know, but yeah, overall, I think I could have done better. Yeah, I mean, I could have done better for sure, but I spent a lot of time learning on doing this problem, and um, sometimes that's all that is. I think I was exploring different ways of kind of doing it. I think I was just a little bit lazy. I think I just went straight for the obvious optimization one instead of spending 20-25 minutes on the exhaustive search. Then clearly I would have been in the top 25. But it is what it is, right? Like, and there are a lot of good people ahead of me. So, but yeah, overall, a good contest. I suppose to end the year, last lead code of the year. But anyway, hope y'all enjoy the rest of the year and have a good new year. And hopefully not too many 2020 puns in your life. But if you like this video, hit the like, hit the subscribe, hit all the random buttons. I'll see you next year.